going. Okay, so we've got our first question is synthetic division. So I'll demonstrate this process for you. This is the question. We have a cubic, x to the 3 plus 4x plus 5 divided by x take 2. So I'll show you how we're going to set this one up. Because we're dividing by x take 2, we're going to take that number, take the mod, as a factor. Like if we have x take 2, then 2 is the root. So 2 is going to be our number. And then in here, I'm just listing the coefficients of each term. So how many lots of x to the 3 do I have? I have 1. How many lots of x squared do I have? So we need to list all of them in degree order. So I've got 1 lot of x to the 3, I've got 0 lots of x squared, 4 lots of x, and then 5 is my constant. I'm sorry, I've drawn this around the wrong way. It looks the same, doesn't it? It goes like this. It should be upside down. Yeah, just tricky. Okay, so this algorithm that we're going to use, called synthetic division, it only works for linears. So we can see we're dividing any polynomial by a linear. It's a much faster way of doing it. It's going to be the fastest way to do it. The reason we do the log division algorithm is because we need to divide by quadratics, right? So it makes sense to start with linears and then progress to quadratics. But here when you need to divide by a linear, this is going to be the fastest strategy. So we've all got that set up. Our very first step is always to put a 0 here. Okay? And then we go like this. 1 plus 0 is 1. Okay. Then we go 1 multiplied by 2. 1 times 2 is 2, so we're going to put 2 there. And then we just repeat. 0 plus 2 is 2. 2 times 2 is 4. 4 plus 4 is 8. And then 8 times 2 is 16. 5 plus 16 is 21. Okay? Now draw your little box at the end here as well, because that last digit that we have, that's going to be our remainder. And this part here is going to be our quotient. Alright? So we've performed this division. Alright? And so another way we can represent that, remember if we have one polynomial divided by the divisor, we could write this as 1 lot of x squared plus 2 lots of x plus 8. Okay, that's the quotient. Plus the remainder, which is 21, on top of the divisor, which is x take 2. Alright, so this polynomial division can be represented like this. That's the second way we learned to represent them. Alright, remember if we have, let's write both of them up here and we'll talk about the relationship between q of x, d of x, plus the remainder. Okay, that's the first way we learned that we can present a polynomial with division. Or if we have p of x on top of d of x, which is what we have up here, right? We have the polynomial on top of the divisor. We can write that as q of x plus the remainder on top of d of x. Alright, so if you divide this by d of x, that will cancel, and you're left with the remainder on top of d of x. Okay, so they're the two ways we can present it. Very good, let's move on to the next one then, and just repeat the process. Here we have a quartic polynomial. So I have x plus 5 is my divisor. We have 3x to the 4, take 5x squared, plus 3x plus 2, and that's all on top of x plus 5. Alright, I'll come over here for it. So because we have x plus 5, alright, the root, the solution would be minus 5. That's the number we're putting out the front. And then we're just listing the coefficients. I've got 3 lots of x to the 4, 0 lots of x to the power of 3. Okay, don't forget that. Minus 5 lots of x squared, 3 lots of x, and positive 2 lots is my constant. Okay, so all you're doing, taking the coefficients of each term, consider whether it's positive or negative, that goes in there. Okay, step 1, we start with a 0 here. 3 plus 0 is 3. 3 times minus 5, minus 15. 0 plus minus 15 will be minus 15. Minus 15 times minus 5 will be positive 75. Minus 5 plus 75 will be positive 70. 70 times minus 5, minus 350. Okay. 3 plus negative 350 will be negative 347. Negative 347 times negative 5 will be, just do it quickly in my head, negative 17, positive 1735. The negative times the negative. And then 2 plus 1735 will be 1737. Alright, so that's a pretty nasty one just because we had to multiply big numbers in our head. But remember, you have your calculator from now on, so any of those you can do on your calculator. I've seen kids in the previous test like type in 2 times 0 into their calculator just to make sure, you know. Alright, so let's write the answer for this one then. When we divide this polynomial by this divisor, it is 3 lots of x to the power of 3. Okay, how do I know it's x to the power of 3? Well, if we divide a quartic by a linear, the leading term is going to be x to the 3. If we divided a polynomial to the power of 5 by a linear, the leading power would be to the power of 4. So it's just x to the 4 divided by x gives you x to the 3. That's how we're getting that. Also, there's 4 terms, right? So x to the 3, x squared, x, and the constant. So we have 3x to the 3, take 15x squared, plus 70x, take 347. So just taking those numbers, chucking the respective power of x on top, and then we have our remainder, 1737, all on top of the divisor, which is x plus 5. Very good. Let's get you guys to demolish this. We won't spend too long on it. I think it's a pretty straightforward algorithm. So have a bit of a look, see how you're feeling about synthetic division.